Good morning, class. As promised, I am making a recording for you in support of the Urban Heat Islands assignment. And so I'm going to get right to it here, share the screen. And so here is the course website. And so the Urban Heat Islands assignment is an essay, and here are some of the reading materials that are accompanying the essay assignment. So here you have the Urban Heat Islands fact sheet, some interesting videos just to give you a little bit of background on Urban Heat Islands. A lot of it comes from an educational or teaching standpoint, so you might have to wade through it a little bit. But these videos will really give you a good idea of how the data are or were collected for this particular assignment. Unfortunately, we could not actually go outside and collect the data, but if you watch portions of this Urban Heat Islands Effect data collection demonstration, you'll get a good idea of what we would have done in order to get the data that we will be working with for this assignment, for the mapping portion of the assignment. Now, for the essay portion of the assignment, this Urban Heat Islands albedo and surface cover presentation is a really good presentation for you to look at in terms of really understanding what we're trying to get at in terms of data, atmospheric science, and so on as it relates to cities. Essentially, when the data are collected outside, the main term is albedo. And so again, become familiar with that term as with regard to different land surfaces and how much heat they produce or how much heat they do not produce. And so various surface covers with different albedos can have different effects upon a city's heat. And you should read about that in this very good PowerPoint presentation called the Urban Heat Island Effect, Albedo, and Surface Cover. This one is the one that you really should read along with some of the other materials. And then, of course, there are readings on urban heat islands mitigation. We have the Louisville Heat Management Study. Then there's this document, Health, Equity, and Impacts of Extreme Heat. This is where we not only look at urban heat islands as a phenomenon, but how do cities and urban regions go about lowering their heat so that we have less incidence of asthma, less incidence of respiratory illnesses that are related to elevated heat. I believe during the lecture last week, I shared that the city of Los Angeles is painting its streets white, which will increase the albedo of those streets, which effectively will lower the temperature of the city by a couple of degrees Celsius, which will in turn result in thousands of less emergency room visits for asthma attacks for children. And so you can see how all of this is intertwined. Engineering, health, and atmospheric science are all involved in this issue. So again, just to review the assignment itself, Module 10, you are required to, among other things, As we go into the assignment itself, you are to only do the essay portion. So what I'm about to do is walk through the GIS assignment. Ordinarily, you would have done the assignment as an assignment. You would have created this map that I'm about to walk you through, but I thought that that would be not as rich of a learning experience because we're using data that was collected a year ago by one of my other classes, and it would just be a little bit abstract. But hopefully by watching the videos, you will get an understanding of what we would have done had we gone outside and actually collected the data and then pulled it into ArcGIS Online and done some form of assessment. So this first part of the assignment, I'm going to demonstrate for you. And that includes, getting an ArcGIS Online account. Again, there is a data collection sheet that we would have filled out had we gone outside. We would have gone and filled out these various portions of the data collection sheet. We would have been on campus, might have divided you up into one or two groups, perhaps. In order to determine the latitude and longitude of our surface and air sample sites, we would have used a global positioning systems receiver or a mapping app on your phone. We would have gone through we would have identified the cloud cover percentage, cloud type, because that would have given us an indication of how much solar radiation was striking the area. We would record the time. Time of day is very important, as you'll see later on. And then, of course, we would have recorded the surface temperature and ambient air temperature in degrees Celsius. Then we would have entered those data into a spreadsheet and then input those data onto a map using proper symbology. So here's the data that we would have collected, and so it's sideways, but the main thing that you should note is that we would have collected the ambient temperature and then the surface temperature of various surfaces. We would have used a GPS receiver to get latitude and longitude. So this is a data table that's included just for your own edification. So we would have transferred data from these sheets onto an Excel spreadsheet. And so here is the Excel spreadsheet, the data pulled into it. And let me just go through this spreadsheet just to show you exactly how the exercise would have proceeded. So here we have a group from last April. We went outside near the old courtyard. And so the goal was to get the ambient temperature using a liquid filled thermometer and the surface temperature using an infrared thermometer. So the infrared thermometer is an electronic device that if you watch the video, you'll see how it's demonstrated. Essentially, it's the same kind of device that you will see pointed at people's foreheads to scan their temperature to see if they might be suffering from COVID-19 or might be infected with COVID-19. It's the exact same type of instrument. And so the way it works is that it detects infrared radiation that's being released from the Earth. So incoming solar radiation is short-wave radiation, otherwise known as ultraviolet. Ultraviolet radiation does not warm up the Earth's troposphere. The troposphere is the lowest level of the Earth's atmosphere. Now, the stratosphere, which is the next portion of the atmosphere above that, which is about 6 miles away from the Earth's surface and above, the troposphere contains the ozone layer. And so the ozone is a gas. Its chemical symbol is O3, 3 oxygen molecules together. Now, in the stratosphere, ozone is good. It blocks those ultraviolet radiation waves and protects us from those UV rays, which can be very damaging. This is why you put that sunscreen on your skin, and it doesn't matter how dark you are. Even dark people can be affected by ultraviolet radiation. Even dark-skinned people can become victims of melanoma, otherwise known as skin cancer, which is the most common type of cancer. And if it's left unchecked, melanoma can spread to other organs and become deadly, actually. So we put on sunscreen to protect ourselves from the ultraviolet radiation, but that's not the radiation that warms the atmosphere. What happens is those UV rays are absorbed by the Earth, and then that energy is released as long wave radiation that is then absorbed by carbon dioxide, water vapor, and other methane and other what we call greenhouse gases. Okay, so that's the process. So the liquid field thermometer is what we would use to get the ambient air temperature. We would use the infrared thermometer to detect the surface temperature, and then we would compare those two. And so what we would have done, if you look at field, the land cover field, we would have looked at, say, concrete in the sun, and then maybe someplace that has brush in the shade, grass in the sun, concrete in the shade, mixed up different surfaces with different levels of incoming solar radiation, just to see if there are differences in these surfaces. And there will be. Now, one of the things that we have to pay attention to is, of course, the time of day. And that'll come into play when we look at our data here. So our first sample site was in the northwest corner of the old courtyard, about 40 meters east of the northeast corner of Boswell Hall. And the students last semester got a surface temperature of 22.86 degrees Celsius and a current temperature of 25 degrees Celsius for concrete in the sun. Now, ordinarily, we would expect to have for that temperature to be elevated, but because of the time of day, we actually saw that the surface temperature was cooler than the current temperature. Well, why is that? Shouldn't the concrete be hotter than the ambient temperature? Ordinarily, yes, but remember this was at about 10 o'clock in the morning, and what happens is those concrete surfaces will lose heat faster than other surfaces overnight. And so because we only had we had a 30% cloud cover, it wasn't a cloudless day, all of those factors resulted in that concrete perhaps not heating up as fast as it ordinarily would. I'm going to come back to that. Let's look at our next surface. We have brush in the shade. And now in this case, the surface temperature is cooler than the current temperature. And just for, to make you familiar, in case you're not, 22 degrees Fahrenheit is about 73 degrees, 22 degrees Celsius, 22 degrees Celsius is about 75 degrees Fahrenheit, just to give you an idea of the temperature. So it's not just a pleasant morning, not very hot, not cool, pretty, warm, but not hot, actually. So that just gives you an idea. This was on April the 3rd of last year. So early April, early spring, still we haven't gotten into the 80 and 90 degree temperatures that we'll get into later in the year. Just to give you an idea of the time of year it was when we were outside. So in this case, the brush and also in the shade was expectedly cooler than the current temperature. now the students went out in the sun and got on the grass, and we saw the grass in the sun had a higher temperature by about 6 degrees Celsius than the current temperature. Well, why is that? Well, again, the grass or the natural surface would retain heat longer and perhaps warm up a little bit more at first during the morning hours. And also this, once the sun strikes it, that would perhaps elevate the temperatures at first. If we go to our next surface, concrete in the shade, same thing. We have about we have cooler temperatures with this concrete now in the shade, even cooler than the concrete that was in the sun, which shows that perhaps that concrete that was in the shade lost even more heat overnight, and that the concrete that was in the sun actually had warmed up about 7 degrees Celsius higher. However, we can see that the effect of the sun did create a difference there. Now we move to the asphalt in the sun. Now we can see how albedo, and in this case, the low albedo of the asphalt, results in quite a striking difference between the temperature and the of the air versus the surface temperature of the asphalt. Remember, asphalt is a black surface, and it tends to warm up very quickly. And so the 32 degrees Celsius, that's about 90 degrees Fahrenheit compared to 70 degrees Fahrenheit. So now if you're thinking in degrees Fahrenheit, that's a 20 degrees Fahrenheit differential. And this is prior to 11 o'clock in the morning. We already have this surface at 90 degrees Fahrenheit on a day where the ambient temperature is about 70 degrees. And so there's where we can really see where a low albedo surface can become quite hot, even early in the day. And so you can imagine that if we were to do this same experiment maybe in the afternoon, we might see temperatures of over 100 degrees Fahrenheit on that asphalt. Okay. And then, of course, we get to the asphalt in the shade. Again, interestingly enough, we see still almost a reversal where that asphalt overnight lost heat, hadn't quite gained it, especially with it being in the shade. So a very interesting data collection went on last year. And so now the next step would be to convert this data table into CSV format. And then we will pull the data into ArcGIS Online. So here's ArcGIS, and we're going to go to Add Data, and I'm going to get Layer from File, and I'm going to go to Choose File here, and we're going to get the CSV file. Here it is. Open, import layer. Okay, and so now here are our data. So the first thing we want is the current temperature data, and we see the symbology there. Hit done. Now, in order to get the second, well, let's just call this, let's rename this layer current temperature, or we would call it the, or we could call it the ambient temperature. Let's just call it, let's give it the scientific term. Ambient temperature. So this is the temperature that we would collect with the liquid filled thermometer. And now let's bring that same data table in again. And so this again is showing you how to get multiple layers onto your map. pull that same table in again in CSV format. And then this one we will set to surface temperature. And then we will call this, we will rename this one surface temperature. So this is the data that we would have collected using the infrared thermometers. And we understand that it's in degrees Celsius. So let's see, let's take the, let's work with these colors a little bit. So I'm going to go to the ambient temperature and let's opt to turn that one maybe a shade of green, perhaps, or maybe blue. Blue might work better. Let's just see blue. Let's make our transparency 50% and hit OK. So that's our current temperature or ambient temperature. And now let's go to our surface temperature. And we want to get something that really contrasts with the blue. And so let's make this red. And so because in terms of, red is an intuitive color. You intuitively think of something that's hot, think of red. And so let's try that, 50% transparency, hit OK, and then done. And just bring our legend back. And so finally, let's change our base map so that we have a surface that we're a little bit more familiar with, so we can see the campus here at Tennessee State University. One thing you'll make note of, just as an aside, notice that a lot of the buildings, or pretty much all the buildings at TSU, and a lot of these buildings were built 50 and 60 years ago. And of course, they have the typical black asphalt roof. So you can imagine that those roofs might increase the temperature from 20 to 30 degrees Fahrenheit. Think about how that's going to affect the cooling costs for those buildings. And so that's why we have what we call green roofs, because as you can see, the vegetation, if you had a green roof or green wall, that would significantly lower the temperature of those buildings. And so in engineering design and in urban design, using green materials or natural materials is used to lower the temperature in buildings, especially here in the Sun Belt. And that would result in great energy savings, which is important to a place like Tennessee State University, where we're affected by budget cuts, and there's going to be less students perhaps in the future. And so we, as an institution, have to be very cognizant of anything that costs money that it should not. So let's go over here to Crouch Hall and notice we have a sample site. Let's look at this sample site. I'm going to click on this sample site, and if you notice clearly with this sample site, we have a higher surface temperature than the ambient temperature. And so you can clearly see that the ambient temperature is maybe around 19 degrees Celsius, and the surface temperature is approximately 32.7 degrees Celsius. This is where we have the asphalt in the sun, and the symbology clearly shows that in this location we have a surface that produces a lot of heat. Maybe what would happen if we turn that asphalt to a lighter color, say white, or some other lighter color? How would that affect that temperature differential? It might affect it quite substantially. On the other hand, if we go to This location here, notice in this case, there's a lower temperature. The surface is, this is where we had the concrete in the sun. But perhaps what we would more commonly expect to see is here is brush in the shade. So here's a green surface in the shade, and we see the effect that that has on temperature. Much closer, there's a much closer relationship between the ambient temperature and the surface temperature as a result of the cooling effect brought on by those green plants. And so when we use natural materials, even living materials, to mitigate temperatures, or in some cases, even for flood mitigation, that's called green infrastructure. That's called the green infrastructure approach to urban design. And so let's look at another location here. Here is grass in the sun. So if we compare grass in the sun versus asphalt in the sun, you can see that this grass results in much less elevated heat than does the asphalt. And so this is why a lot of community designs, a lot of residential communities try to preserve green space as much as possible, because in residential and commercial development, developers now realize that because of the energy savings involved, and to some degree the aesthetics, that green space can actually add value to residential and commercial property. That hasn't always been the case. There were times when developers would try to clear as much of that green space out of the way as possible so that they could cram in as many homes per acre as possible. But developers are now realizing that people like green space, like to have places where there's greenery, and people are willing to pay more for that. Even commercial development and design. It's more attractive, and it's healthier, and it can lower energy costs for businesses and residences. So for all those reasons, outside of the physics behind this, which you can clearly see the physics on this map in display, then we can see what incentivizes developers to retain green space. And so this is the exercise that we would have gone through. This is the map that you would have attempted to produce. And the symbology, as you can see, clearly conveys to the map reader using the legend the difference between surface temperatures and current temperatures at the same location with different methods of sampling. And so we would save our map here. Save it. I would call this, in this case, Urban Geography 4850 UHIE demo. And I guess same tag, Urban Heat Island. I'm going to save the map, and then I'm going to go to the map, share, public, scroll down, hit this done button, and then we would have just taken this link to the map and shared it to whomever we would like to see our work. So that essentially is just a demonstration of the GIS portion of this assignment. And so there's a part of your essays, which is what you have to complete, that addresses that. So the first part of your 700 or more word essay is to describe how, Okay, the first part of the 700 or more word essay is to Describe how the map and the data produced with the exercise bolster your understanding of the physical science associated with the urban heat island effect, i.e. albedo, surface temperature, how do various surfaces affect temperature, incoming solar radiation, greenhouse gases. All of those are inherent in this lesson. And then the map symbols, that's where you really should be able to become cognizant of what is happening at any location on the ground. And that's specifically what we try to do with mapping, is take a concept or take data that you would find in a table or a chart and visualize it so that an individual reading the map can clearly see, oh, this concrete is getting a lot hotter than the grass, right? Compared to the ambient temperature. Any reasonable person should be able to see that on those maps with those map symbols properly displayed, having a color ramp that conveys the message to the eye of what's happening physically on the ground. Next, you might have to reach beyond into looking at environmental justice, climate justice, racial health disparities. How are all those inherent in the urban heat island effect? And so you can definitely do some research and look up some articles and information on the relationship between urban heat islands, environmental justice and climate justice, and racial health disparities. I gave you one clue about the prevalence of asthma in African American communities, and that is why it's pretty obvious that African Americans have to be concerned about urban heat islands. And of course, those same populations are vulnerable to COVID-19. And I think I included an article in there that looks at COVID-19 and heat. How is that going to play out once we get into the hotter months? Now, we would hope that COVID-19 is going to be tampered down because of the heat, but if it is not, knowing how heat affects people who have respiratory issues, and a lot of those people who have respiratory issues happen to be African American, there are some issues of concern there, obviously. Then, of course, when we get to the last part of your essay, what about strategies for mitigation? What about policy, public policy, urban design, green infrastructure? How can cities lower their temperatures and mitigate the negative effects and externalities associated with the urban heat island effect? And so again, on Wednesday, we will engage in this discussion along with the discussion about urban food deserts. So if you have any questions, please let me know. And as usual, think work, sir.